Do you feel the vibes?
Hey guys, okay, so last time we went over how to graph exponential functions, and we talked about growth and decay, we discussed that if you have a negative in front of the function, that's a reflection on the x-axis. Okay, so today we're going to move from that, and we're going to talk about what happens if you have a different factor in front. Okay, so let's start with that. So here we have f of x is equal to 3 times 2 to the x. The asymptote is again y equals 0, right? That is the default asymptote unless there is a vertical shift, which there isn't in this case. The y-intercept is f of 0, which is equal to 3 times 2 to the 0, which is equal to 3 times 1, so 3. So I would write that as 0, 3. All right. Now, this one is again growth, right? Because you see here, it's 2 to the power of x, and the number that's being raised to the exponent is greater than 1, so that is growth. For growth, again, I pick -1, 0, 1, and 2 to plug into my function. So here, we're going to do 3 times 2 to the -1. This is equal to 3 times 2 to the -1 is 1 over 2, which is 3 over 2. 3 times 2 to the 0, we just did that. That's 3 times 1. 3 times 2 to the 1 is 3 times 2. 3 times 2 to the 2 is equal to 3 times 4, which is equal to 12. Okay, so let's go over here. The asymptote is again y equals 0. Let's put in our points. At -1, it's 3 over 2, which is 1.5. Right there. And then at 0, we're at 3. Whoops, 3. And then at 6. And 12 is off the grid, so I don't have to label that one. And I graph right there. Okay? Awesome. All right, the domain of all exponential functions is all real numbers, -infinity to infinity. And the range is from 0 to infinity. Okay, so remember, this number is always going to be the same value as the asymptote, right? And you're either going to go to infinity or -infinity and so on. Okay, so let's take a look at this one. This one, immediately we see there is a negative in front, so that's going to be a reflection. The asymptote is again y equals 0. The y-intercept is f of 0, which is -3 times 3 to the 0. -3 times 1 is -3. So we write it as 0, -3. Awesome. Okay. This one, again, is growth because the number that's being raised to the exponent is greater than 1. So I'm choosing -1 to 2. So let's see what happens here. This is -3, 3 to the -1. -3 times 1 over 3, -1. -3, 3 to the 0, -3 times 1. -3 times 3 to the 1, -9. And then -3 times 3 squared, that's -27. All right, so obviously I'm not going to graph that one. Okay, so here we go. Asymptote, lovely. At -1, we're at -1. At 0, -3. At 1, already at -9. That -3 in front really makes it, go down even faster. And I graph like this, and there you have it. Okay, domain, always all real numbers. The range Okay, so now this goes from negative infinity to 0. All right, awesome. So remember, always put, the negative infinity first, then 0. So you always have to go from the smaller valued number to the bigger valued number, okay? All right. Now, so that's if you had a factor of a in front. Now, what if you have a horizontal shift, right? Well, take a look at this one. In this example, we have 5 to the power of x minus 2. The exponent is no longer x. Now it's x minus 2, right? The exponent has changed. That means this is a horizontal shift to the graph. So how do you know which way you've shifted? If it's in the case of an exponent, you take your exponent, set it equal to 0, and solve for x. So x is positive 2. Because it's positive 2, we say it's shifted to the right by 2 units. Okay. Now, the shift is happening, right, left, not vertically. So the asymptote is still at y equals 0. The y-intercept, we find it in the same way. F of 0 is 5 to the power of 0 minus 2, 5 to the power of negative 2. Now, this is equal to 1 over 5 squared, 1 over 25. So it's 0, 1 over 25. Okay, this is still growth, right? Because it's 5 to the power of an exponent. All right, so let's see what's going to happen here. Again, I'm choosing these, but again, I've said over and over, these are not like set in stone. They're just a good guideline, but sometimes you might have to modify it like we might in this case. So here I have 5 to the power of negative 1 minus 2, 5 to the negative 3, 1 over 5 cubed. Okay, that's 1 over 125, right? Okay, that's silly. That is too small a number to graph. Okay, so let's see what else we have. 5 to the 0 minus 2, we just did it. It was 1 over 25. Okay, that's a y-intercept, right? That's an important one. I'll live with that. 5 to the 1 minus 2, 5 to the minus 1, 1 over 5. 5 to the 2 minus 2, 5 to the 0, that's 1. Okay, so look at how tiny these numbers turned out. So you know what? Like in this case, I'll just add in an additional number. 5 to the 3 minus 2 is 5 to the 1, which is 5. Okay, those are better numbers to graph, right? So let's do this. Okay, 0, 1 over 25. I mean, that is like really close to the asymptote. 1, 1 over 5. Okay. Then at x equals 2, y equals 1. At x equals 3, y equals 5. So when I graph, it's going to look like this. Okay? All right. So my domain is, again, all real numbers. And the range, right? So this goes from 0 up to infinity. Fabulous. Okay. One more. Now in this case, I have 1 over 3 to the power of x minus 3, right? In this case, this negative 3 is responsible for a vertical shift to the graph. In the case of the vertical shift, you just take it at face value. Negative 3 means it's shifted down by 3 units. Now, when you shift the graph up and down, the entire thing shifts up and down, including the asymptote. So the asymptote now is also going to be changed to y equals -3. It is always going to be the same as whatever number that is. Y equals that number. So in here, my asymptote is y equals -3. The y-intercept, same situation, 1 over 3 to the power of 0 minus 3. 1 minus 3 is -2. So it's 0, -2. Okay, now, in this case, take a look here. The number that's being raised to the power of x is 1/3. That's between 0 and 1. This is decay. And because of that, I chose these numbers, -2 to 1. All right, so let's see what happens here. 1 over 3 to the power of -2 minus 3. Okay, 1 over 3 to the power of -2, we're going to take the reciprocal. So 3 to the 2 minus 3. 9 minus 3 is 6. Okay, 1 over 3 to the -1 minus 3. That's 3 to the 1 minus 3, 0. 1 over 3 to the 0 minus 3. I just did that. That was my y-intercept, and I got -2. 1 over 3 to the 1 minus 3. That's 1 over 3 minus 3. And you can even do that with your calculator. That's -8 over 3, right? Which is -2 and 2/3. Okay, so let's put up our asymptote. Y equals -3 is our asymptote this time. Right. Now, at -2, we're at 6. At -1, we're at 0. 0 minus 2. Then -2 and 2/3. So let me graph this. Fabulous. Okay. The domain is again all real numbers. Now the range, right? Remember, it's got to be connected to this number, right? And because it's sitting above the asymptote, it goes from -3, the asymptote, up to positive infinity, right? Okay, so there you have it. This is the lesson for today. Okay, you're gonna do the worksheet. It's graphing day 2, right? Or worksheet 2. Now, very, very important. For the next class, you must have your graphing calculators with you because we actually have to use that. Okay? All right. Have a good day, everybody. Bye-bye.
Press start.